All right, guys, before we get started, are there questions over any of the homework assignments? Questions on the homework problems? Questions on the homework? What we're going to be doing today and starting today is solving radical equations. If two expressions are equal, then the squares are equal also. So we solve radical equations. There's going to be several main steps that we're going to do to solve these here. Now the first step, and first thing we're asking ourselves, is there one radical? If so, if there is, get it by itself. If not, even them out. If there's more than one radical term, we're going to even them out. We want either one on either side. If we have two, if we have three, two on one side, one on the other, we need to try to even them out as best as possible. We don't want them all on the same side. Once we get them set up, we get the radical by itself or even it out. We put both sides to the nth power. So if we're talking about square roots, we're going to put both sides to the second power. If we're talking about cubed roots, we're going to put it to the third power, and so on and so forth. Step 3, are there any radicals left? If so, repeat steps 1 and 2. If not, solve. So these are the 4 main steps for solving our radical equations. And as we look at this first one here, we have the square root of x plus 5 equals 13. First step, is there one radical? Yes, we just have the square root of x. We don't have any other terms with it. And since there's just one, we need to get it by itself. We don't need anything added to it or multiplied in front of it. So what is the first thing we can do with this here? We can subtract 5 from both sides. Because here the 5 minus 5 is 0, telling us the square root of x is equal to 13 minus 5 is 8. Is the radical by itself? Yes. So that means we can go on to step 2. Put both sides to the nth power. So what would our nth power be? 2. Because here the square root and square would cancel, giving us x by itself. Now squaring both sides, putting both sides to a power does not give us the plus or minus. We don't use that when squaring both sides. 8 squared is 64. Questions on this here? And we can check this here to make sure it works. So we'll plug 64 back in for x. So if this is the correct solution, the square root of 64 plus 5 should give us 13. And we could plug that in. Square root of 64 plus 5 is 13. So 13 is equal to 13. That checks out, telling us that x equals 64 is our solution. Any questions on this here? All right. Let's look at the next one. 3 minus the square root of x equals 0. Is there one radical? Yes. So we need to get it by itself. What's the first thing we can do to get it by itself? We can minus 3. We can subtract 3 from both sides. Telling us negative square root of x is equal to negative 3. Is the square root of x, is our square root by itself? No, we have the negative. We can multiply this by negative 1. We could divide it by negative 1. Either way, we will get the same result. Because negative 1 times negative square root of x is going to be positive square root of x. Negative 3 times negative 1 is 3. So is the radical by itself? Yes. So we're going to put both sides to the second power, the nth power. Because on the left-hand side, our square root and square would cancel, giving us x. 3 squared is 9. And if we check this here, we're trying to say that 3 minus the square root of 9 is 0. And luckily for us, we can type all that in. 3 minus square root of 9 is indeed 0. So 0 is indeed equal to 0. So x equals 9 is our solution. Questions on this here? Square root of x equals 6. Is there one radical? Get it by itself. It is by itself. So that means we can just go to step number 2 and put both sides to the nth power. Again, our nth power is 2. Because our square root and square would cancel, leaving us with x by itself. 6 squared is 36. So x is equal to 36. And if we did check this here, all we're saying is that the square root of 36 should equal 6. Well, the square root of 36, 6 times 6 is 36. So 6 is indeed equal to 6. Questions on this so far? Square root of x minus 7 equals 3. Is there one radical? Yeah, get it by itself. What can we do first? Add 7. Because our negative 7 plus 7 is 0, leaving us with the square root of x. 3 plus 7 is 10. Put both sides to the nth power. And the power is still 2. Because the square root and square would cancel, telling us x is equal to 10 squared or 100. These steps? Yeah. Square root of 100 is 10. 10 minus 7 is indeed 3. So x equals 100 is the answer. Questions on this here before we look at the next one? Square root of y is equal to square it. Square root of y squared is going to be y. 7 squared is? Questions on this here? I think we feel comfortable with these here, yes? All right. Is there one radical? So get it by itself. What would we do first to get the radical by itself? Subtract 3. So those would simplify to 0, leaving us with 4 times the square root of x plus 2 is equal to 16. Is the radical by itself? What's with the radical? Divide by 4. Since 4 and that radical are being multiplied, we'd have to divide, because 4 divided by 4 would give us 1, leaving us with the radical of square root of x plus 2. 16 divided by 4 is 4. Is the radical by itself? Yeah. Is there anything else in front of the radical being multiplied? Anything added to it? No. So we'll put both sides to the nth power. Well, our nth power again is 2, because the nth power in that index will match, leaving us with x plus 2 is equal to 16. And really at this point, x has been by itself. So step 3, are there any radicals left? No. So now we actually need to solve. Subtract 2. Minus x is equal to again, if we're checking this here, we're saying that if x is 14, 4 times the square root of 14 plus 2 plus 3 should be 19. So 4 square root 14 plus 2 plus 3 is indeed 19. So 14 is the correct answer. Questions on this here? All right, let's look at a similar one. 3 times square root of x plus 5 minus 1 equals 11. Is there one radical? So how do we get it by itself? Add 1, telling us 3 square root of x plus 5 equals 12. Yes. Now we're going to divide by 3 because the radical isn't completely by itself. This 3 and this 3 will cancel, telling us the square root of x plus 5 equals 4. Then we put both sides to the nth power. Our nth power, again, is going to be 2. Because square root and a square will simplify each other out. Telling us x plus 5 equals 16. Subtract 5. Telling us x is equal to 11. That's it. Questions on this here? Are you ready for the next one? We feel comfortable with these here. Because we'd subtract 7, square it, and then subtract 4. All right. Example 3, the square root of 2x minus 1 equals the square root of x plus 4. Yep. Is there one radical? No. If not, even them out. So we have how many? 2. So if I even them out, I want 1 on either side, yes? Are they evened out? Yeah, okay, let's go to the second step. Put both sides to the nth power. Now, for the most part, we're going to deal with them being the same power. If they're not the same power, it does get a little tricky, but it's not too bad. Because it's going to be figuring out what power is going to make that radical go away. Here, squaring. So if we look at the left-hand side, we have the square root of 2x minus 1 squared. Well, the square root and square would cancel, leaving us with 2x minus 1. On the other side, the square root and square would cancel, leaving us with x plus 4. Now, this works because, again, we only have the radical. If it was, say, the square root of 2x minus 1 and then plus something outside, we'd have to actually multiply it out. Yep, now we just need to solve. We can subtract x. 2x minus 1 is equal to 4, yes, and add 1. Telling us x is equal to 5. Now again, we can check and make sure, because we're saying 2 times 5 minus 1, square root of it, is equal to the square root of 5 plus 4. Square root of 2 times 5, is it minus 1? 2 times 5 minus 1 would be 9, and square root of it is 3. On the other side, we have square root of 5 plus 4 is also 3. 3 is indeed equal to 3, so our value of x is 5. Questions on this here? Well, we have more than one radical again, so we need to even them out. They're already evened out. Square them both. Because here the square root and square would cancel. Square root and square would cancel, telling us 4x minus 3 is equal to x plus 9. Okay. All right. What do we need to do next? Yeah. We can add 3 to both sides. We could subtract 9. I prefer adding 3. Yes. Because if we add 3 to both sides and then subtract x, our x term stays positive. Because if we subtracted the 4x, we'd get negative 3x and then have to divide by negative 3. Still get to the same answer. But if I can avoid negatives, it does make things a little bit nicer. Questions on this here? All right. Square root of 3x plus 1 minus the square root of 4x minus 7 equals 0. Is there more than one radical? Even them out. So if we add the square root of 4x minus 7 to our negative 4x minus 7, what would that give us? Yeah, because I'm adding to a negative. Really, we're taking 4x square root of 4x minus 7 and subtracting from it itself, yes? Anything minus itself is 0. So those are gone. So that tells us that I have the square root of 3x plus 1 on one side. Negative square root of 4x minus 7 plus square root of 4x minus 7 is 0. Are they evened out? Now we can put both sides to the second power, that nth power. So these would cancel out, telling us that 3x plus 1 is equal to 4x minus 7. No more radicals, so solve for x. Subtract 3x. 3x minus 3x is 0, telling us 1 is equal to x minus 7, and then we can add 7, telling us x is equal to 8. So far we've seen radical equations where we just had a radical, and we added or subtracted. We had some terms inside the radical besides just x we had to solve for. We've seen now with radicals on both sides, we're having two radicals, we even them out, and it works out fine. I think we feel comfortable with these here, yes? Well, now we're looking at a cubed root, yes? Let's see if anything changes. So let's keep to the same steps, and hopefully nothing changes because it's a cubed root instead of a square root. First step, is there one radical? Okay. If so, get it by itself. It's by itself. So now we need to put both sides to the nth power, and that power would be 3. Because the cubed root and third power will cancel each other out. So these will cancel each other out, leaving us with minus 2 is equal to, fortunately I don't have 12 cubed memorized, 1728. Well, did it matter that it was a cubed root instead of a square root? Doesn't matter what root we take? No, because we're going to put both sides to the nth power, whatever that power is. Now we just need to solve because there are no radicals left. And yes, indeed, we would add 2. Telling us 5x is equal to 1,730. Then we would divide by 5, telling us x is equal to 3, 15. I believe it would be 346. And that's it. Again, we can check. We say the cubed root of 5 times 346 minus 2 is equal to 12. Cubed root of 5 times 346 minus 2 does indeed equal 12. So 12 is indeed equal to 12. It works. Questions on this here? We have one radical. It is by itself, so we're going to put both sides to the third power. And again, the cubed root and third power would cancel, telling us that 2x minus 5 is equal to 3 cubed. Well, I do know 3 cubed. 3 cubed is 27. Now we're going to add 5. That's it. Questions on this here? Cubed root of y minus 4 equals 1. We need to get it by itself, so we would what? Add 4. Telling us that the cubed root of y is equal to 5. Then we would set it to the third power, because putting it to the nth power would tell us that y is equal to 125. Questions on this here? Questions on anything we've done so far? We feel comfortable with these here. That's it.